divide a polynomial by a monomial. Before we look at examples, I want to say a few words about the definitions. What is a monomial? Before we talk about monomial and polynomial, I want to distinguish between two definitions. One is called a factor. The other is called a term. So these are special definitions they have special meanings in mathematics, in algebra. Factor, if the operation in the expression is multiplication, only multiplication, we call each of them a factor. For example, we have negative 12a squared, and notice that this means negative 12 times a squared. And again, a squared means a times a. So the only operation we have in here is multiplication, and so we can call each of them a factor. For example, we can call negative 12 a factor. We can call a squared a factor. If you rewrite a squared as a times a, and again, the only operation in here is multiplication, you can call each of them a factor. So you can call negative 12 a factor, and a a factor. So that's the definition factor. So whenever we talk about factor, the only operation we can have is multiplication. But when we talk about term is, for example, we look at the top here, we have negative 48a to the 6. And if we only have this, and as you can see, we have multiplication, but the whole thing we will call it a term. So there's only one term here. And similarly, like we said, in negative 12 is a factor, and a squared is a factor, but negative 12a squared together will be called a term. And then we can add or subtract other terms. So when we see subtraction, this one means minus, then this is another term. So here we have two terms. The first term is negative 48a6. The second term is negative 12a cubed. So we got two terms. And the difference between factor and terms, factors are separated by multiplications, only multiplication, cannot have addition or subtraction. But terms are separated by addition or subtraction. So when we look at this example, the bottom, apparently we only have multiplication. That's only one term. If there's only one term, that's when we call it a monomial. But the top, as we can see, there are two terms. This is the first term, this is the second term. And we do have a name for this. We can call it a binomial. And if we have three terms, let's say if I add another one, maybe we can do addition this time. We can just add anything, say 7. And then this has three terms, 1, 2, 3. And you can also call it a trinomial. And you may have 4 terms, 5 terms, 6 terms, keep adding or subtracting, and then it's going to be called a polynomial. Pretty much when you have more than one term, we can call it a polynomial. Even if it's a monomial, we can still call it a polynomial. A monomial is just a special case of polynomial. So in the previous video, we only had one term on the top, one term on the bottom. So it's like doing a monomial divide by monomial. So if it's like, for example, if I get rid of the second term and just do this, it's one term on the top, one term on the bottom. That would be monomial divided by monomial. But what if we have two terms, or even more, 3 terms, and so on the top? And how do we divide? So the idea is very similar to distribution we learned before. And so if you remember that when we did multiplications instead of division, so let's recall an example we learned before. So say we have negative 12a squared times something like maybe 3a to the 6 to make the number smaller for us to multiply. And so we will distribute this to what's inside the parentheses. And so when we do multiplication, that means we multiply the term on the front, negative 12a squared, with both terms in the parentheses. So when we do division, it's kind of similar. We're going to divide, we kind of distribute a negative 12a squared to the top two terms. So it's like doing two division questions. So we're doing negative 48a to the 6th, that's the first term, divided by negative 12a squared. And then we also have to do the other one. Let me put a little plus sign here. Well, the two ways you can write. You can put a little plus sign on the top because we know that the plus sign is omitted. And then you're going to have plus negative 12a cubed divided by negative 12a squared. So you divide each top by the bottom. Divide the first one by the bottom and divide the second one by the bottom. If you don't want to put a plus sign here, you will have to write down this minus sign. So the other way is you can put a minus sign here, but the top will be positive. It's like a minus, keep this minus, and then 12a cubed divided by the bottom, negative 12a squared. So the bottom, the whole thing, including the minus sign, has to be distributed to each top, but it will stay on the bottom. So including the minus sign. Okay, so either way is correct. Now we have negative 48a6 divided by negative 12a squared. We talked about dividing monomials before. We divide each one, divide the numbers by the numbers and the base a's by base a's. So we do negative 48 divided by negative 12, that's a positive 4. a6 divided by a squared, that's a to the 4th by using the formula of subtracting exponents. And then there's another minus sign. We keep it. And we'll divide these two. We also do the same thing. We divide 12 by negative 12. That's a negative 1. And a third divided by a squared, we get an a. Because 3 minus 2 is 1. And usually we like to get rid of parentheses. And in this case, it's just you can use keep, change, change to get rid of parentheses. Keep, change, change, because it's subtraction. So we get a 4a to the 4th plus 1a. Two plus signs, we can omit one of them, and the 1 can also be omitted. And so that's the final answer. And a lot of steps can be omitted, like even later when you're familiar with this process, you can skip both steps. So when you do that, you can do this in your head. You can do negative 48 divided by negative 12, which gives us a 4. a6 divided by a squared, that gives us a 4th. And then when you are done dividing the first term by the bottom, you would divide the second term by the bottom. Negative 12 divided by negative 12, it's positive 1. The 1 is omitted here. A third divided by a squared, that gives us a. So these two steps can be omitted if you can do it in your head. Now let's look at another example. Say if we have negative 30 x to the 5th, y to the 6th, plus 25 x to the 4th and y to the 9th, divided by negative 5 x to the 3rd, y to the 4th. So as we can see, it's the same type. The bottom has one term. It's because it's all multiplication. That's considered as one term. So remember, terms are separated by addition or subtraction. If we only have multiplication, that's considered as one term. But the top has a plus right here. So that tells us there are two terms. To do this, we will divide each one by the bottom. So we divide the first term, negative 30 x 5th, y to the 6th, by the bottom, negative 5x 3rd, y 4th. And then plus the second term on the top, 25 x 4th, y 9th, divided by the bottom, negative 5x 3rd, y to the 4th. If you can't do it in your head, I would write down this step clearly. so we won't make mistakes. But if you can, yes, you can do this step in your mind. And then we're going to divide each monomial by a monomial, because one term on the top, one term on the bottom. And the same for the other one. Okay, so negative 30 divided by negative 5 is positive 6. X fifth divided by x third, it's x squared. We're using a formula we discussed in the previous video. X to the mth divided by x to the nth. We keep the base x. We subtract the exponents. So that's how we get it. Keeping the base x, subtracting 3 from 5. Similarly, keeping the base y, subtracting 4 from 6. Now we do the second one. 25 divided by negative 5, it's a negative 5. Notice that I omitted the plus sign. You can put a plus sign there, but a plus negative 5, the plus sign can be omitted. So you can just write down minus 5. X fourth divided by x third, that gives us x to the first, 4 minus 3. And then y 9 divided by y 4, that gives us y to the fifth. And they are not like terms because the variables don't match and we cannot combine them any further. So we will just leave it as the answer.